we should speak English and try to communicate in English because it's mainly international things, and I know that sometimes it's difficult, but we have now in our session international speakers, so they will speak and present the latest research works in English, and it will be a great pleasure to have with us in this session three of the pioneers on IoT. But just before presenting our guest speakers, just 5 minutes to complete the first session with 5 minutes video of Vinsurf from Google, people-centered internet, and IEEE fellow. So please enjoy his video and welcoming speech, and then I will present our speakers for our session. Please.
Hello, my name is Vince Cerf. I'm Google's chief internet evangelist and sometimes known as one of the fathers of the internet. I want to thank Farouk Kamoun, my good friend, for allowing me to spend a little time with you today on the topic of the Internet of Things and security. I think it would be hard to overstate how important it is to do the design and engineering for the Internet of Things that will protect people's safety, security, privacy, and also make these devices useful. At the same time that we want them to have high utility, we also want them to be functional and to protect people's interests. I would particularly point out that we also need a kind of autonomy. That is to say that if we're going to create a collection of things that are on the internet, that they should be useful even if the internet isn't accessible. So you certainly don't want a home that suddenly stops working because its internet connection isn't available. So we clearly need local autonomy for these devices, in addition to the other desirable characteristics that I've already mentioned. Let's talk a little bit about strong authentication. One of the ways that we can help these devices protect themselves from inappropriate access, either to control or their data, is to assure that the devices can determine whether the party on the other end is in fact a legitimate and authorized party to have access to this device. To do this, we can use strong authentication technology, which is based on high-quality cryptography. I don't want to minimize the difficulty of making this work. People are notoriously unskilled at keeping track of passwords, let alone crypto variables. And so we're going to have to develop an architecture and a system that makes it easy for people to use these kinds of technologies in order to strongly authenticate parties that are using their devices. By the same token, we're going to have to be very careful about protecting the information that's flowing to and from these devices from inappropriate access, which means probably that the streams themselves need to be encrypted. Even something as simple as a stream of temperature information from every room in the house over a period of 6 months could give someone a sense for who lives in the house, or at least how many people are there, how often they come and go, when might they be away. And that kind of information, of course, would be a serious problem if someone wants to break into the house. There's a separate problem having to do with episodic authorization. Let me give you an example. The house is on fire. The fire department is on the way. If the house has webcams, you might want the fire department to have access to the webcams under those circumstances. In other words, the house is on fire, to determine whether someone might be unconscious in one room or another in the house. Similarly, the temperature information might allow the fire department to know which room is hottest and most dangerous. But we don't want these people to have access to this information except under those special circumstances. The same arguments might be made for the police department if the house has been broken into. So we have a lot of work to do to make these systems work well, defend themselves against inappropriate access, and are easy to configure, which leads me to one last point. At some point, we may have dozens, if not even 100 or more devices in someone's home, and certainly in offices and manufacturing plants. When you have hundreds or thousands of devices to configure, you want some help. You want something that will allow you to automate as much as possible this whole process of configuring the collection of devices into a particular control authority. And so once again, we need to have tools that make it easy for people to incorporate new devices into an existing system. Imagine bringing 100 devices to a house that already has 100 and spending a week typing IPv6 addresses. That's something you don't want. Which brings me to one last point about IPv6 in particular. With tens of billions of devices around the world, we're going to need the IPv6 address space. And so please pay attention to that little aspect of the architecture of the Internet of Things and make sure that IPv6 works for the systems that you design. Well, I'm sure I've used up more time than Farouk intended for me to use, but thank you again for listening, and also please accept my apologies for not being able to participate in person. But since I can't see you face to face, maybe we'll cross paths on the net.
So, thank you. Yes. Hello? Okay. Thank you very much for your attention to the speech of Vint Cerf. He's, as you know, the father of the Internet. Unfortunately, is not. It was not possible to that he came to Tunisia these days. He's fully booked. And he promised next year to be with us, and just to announce that he's very supporting to Tunisia, mainly with via Google, IEEE, and People-Centered Internet. They selected the pilot project from Tunisia that aims to teach kids and children in primary schools, in schools in rural area in Tunisia. This is mainly under the IEEE humanitarian program, and we are more than 100 volunteer students. They are organizing several training for kids in the primary schools. So it is a free call who would like to join, to contribute, to help us. Don't hesitate to contact us. The website is under IEEE.tn. And it is a great pleasure to have with us Jan Akidilis from US, from Georgia Institute of Technology. Thank you for coming to Tunisia. Jan, it is a great honor to be with us. Just to introduce Jan, he's the director of the Broadband Wireless Networking Laboratory. Ken Bayer's chair, professor in telecommunications. As I said, Georgia is from Georgia Institute of Technology in Atlanta in US. He's a IEEE fellow, SAM fellow. His papers received over 90,000 citations, and thanks to these citations, he's now ranked on the 15 scientists worldwide, and 37th in US. That's correct? And the hash index is 107 on this month. Congratulations. So he's editor-in-chief of Computer Networks Journal, founding editor-in-chief of the Ad Hoc Networks Journal. Okay, just 2 lines. And of course, received numerous awards. We cannot cite all of them, but congratulations also for this. And his research interests now mainly nanoscale communications, 5G cellular systems, software-defined networkings, and wireless sensors networks in challenged environments. Yeah, of course. So thank you very much for your for coming. Just I will,
the first
this one.
First page. Good morning. While he is fixing my slides, it's 6 o'clock in the morning in the U.S. You can imagine I should be that tired, but I'm surviving. So I would like to thank you for being here. The reason is I travel worldwide and give these speeches. Each time there is a president or vice president or a minister, the hall is completely full. And after he leaves, 2/3 of the people leave. So I was scared that when this minister was here, that you will all be gone. I will have 50 people, but this hall is full. Thank you. Thank you. So that shows that you are very interested in IoT, and I hope I can, there is this noise in the back. Please, if you want to talk, you're welcome to go outside. Did you hear? Hello? Respect, please. So I also would like to thank the organizers, Imad, and also Farouk, Professor Kamoun, who is a longtime friend. So I'm extremely happy to be here for the 4th time. So the first two were many years ago in 1981 in Zarzis, and I found out Fethi is from Bangardin. So I was a young fellow at that time and hippie, and I ended up there, right? So let's go to the Internet of Things, and I have 30 minutes. So there are so many things to say. Yesterday I presented you the micro things, nano things, and bio nano things, and today I will be more focused on the micro things and also more business issues. So hopefully you will get some ideas from this presentation.
Use the clicker.
Oh, which one? Here? Yeah, okay. Good. So what is Internet of Things? I'm sure you know that already. Which one is the
right, this one.
No, the pointer. This one?
Yeah.
Good. So now I do like yesterday, this guy. So Internet connects all people. So we call it kind of like Internet of People. And IoT connects all things, Internet of Things. Also Cisco calls them Internet of Everything, as you know. So the simple definition, there are many definitions. So the simple definition, as I also mentioned yesterday, interconnection of things, objects or machines. What can they be? Anything you can imagine, sensors, actuators, mobile phones, electronic devices, home appliances, anything you can imagine, any item, anything goes. So they are connected to each other, and they use Internet as backbone and communicate with each other, as you see on this picture also. So the Internet of Things, it's really growing exponentially. When you look at this picture in 2003, we had more humans than the machines or things, as you see here, the blue one. In 2010, the things exceeded the humans, and 2015 more, and by 2020, we will have 50 billion things connected to each other. So many more than the humans. Some of you may know that 5G systems are already in the planning. So we are thinking about 2020, 2030, we will deploy them. So the IoT will be a major part. So if you want to play a big role in 5GPP and 5G systems, you can also go through the IoT track. So they are talking about connection of 7 billion people and 7 trillion things. So we can imagine this size of these networks. So major characteristics of these IoTs are very large scale, or actually ultra large scale, right? And heterogeneity, because we will have many devices from different vendors and highly heterogeneous environment. And pervasivity is computing and communication technologies will be embedded in our environments. So there is this 4-layer model of IoT because some people always confuse IoT with the sensor networks or RFIDs. It's not. IoT is the big umbrella. It covers all of them. As you see here on the bottom one, you can have GPS, smart devices, RFIDs, sensors, anything you can imagine. That's the sensing and identification level. And the backbone, you can have network construction. Any network, physical network can support this, like, internet, wireless, WiMAX, or, metropolitan area networks. Anything you can imagine, they will be supporting these devices. And then the information processing, we have data centers, search engines, smart decisions like machine learning, right? All these algorithms, security mechanisms, and data mining solutions will be on this level. And then tons of applications. Like today, we have seen a bunch of young people. So we have some of them are here, logistics and smart grids and green buildings and smart roads, all of that. So you can have many, many of that. Same thing here. By no means these layers are complete. They are just showing the examples how the entire big umbrella of IoT looks like. So everybody talks about Internet of Things outside terrestrial, right? But there are more, by the way. So what about Internet of Underwater Things? So I also did research for Navy for many years. So you can create all these devices under the water, and then they can use the backbone, and you create another Internet of Underwater Things. Or Internet of Underground Things for agriculture, for example, or also soccer field, tennis field. There are many, many applications for the underground things. So it's a big business also, by the way. So this is a new initiative in the United States. They are just trying to get proposals from the US Army. It's called Internet of Battlefield Things. Okay? Then here is another thing, Internet of Space Things. I was visiting University of New Mexico. They have Air Force Research Lab there too. So they showed me that they have this, it looks big, right? But they are like mug size, mug, coffee mug, right? So they have these big, small satellites and large network in the space, and then they will cover also the satellite communications. Here yesterday I talked about Internet of Nano Things. They are much more powerful, and I explained to you all yesterday. If you missed it, then it's okay. Then this is Internet of Bio-Nano Things. So you can put them all inside the body, and then you can initiate these artificially designed machines. And so you can get all the information from the inside the human body. Why can we use it? For e-health, for example. You can detect bacteria, infectious diseases, for example, Alzheimer's, all of the above. So it will also prolong our lifespans. Again, yesterday I talked about it. So the Internet of Things perspective, we are talking about anytime, any place, anything. So anytime is on the move, outdoor, indoors, and night, or anytime. And any place, outdoor, indoor, on the move. And then anything is human to human, human to things, and things to things communication. So they can support any communications, anytime, any place, anything, as you know. So there are these top industries key for IoT applications. Again, some of you also have seen this example about smart grid, mini one here, smart health, smart homes. So the list is long. So you can, everything will be smart, and then all these things will be connected to each other. That's the bottom line. Okay? There are some IoT products, and by the way, unfortunately, maybe it's luck for all of you or us, that the market is not there. You will see it. So it will increase, but all these products are doing okay, but it's not like billion-dollar industry so far, right? So there are also these IoT platforms by the big companies like General Electric's Predix, Cisco IoT Cloud, IBM Watson IoT Cloud, and PTC ThingWorks platforms. Mostly, they are really going more futuristic, looking for softwareization, cloud, software-defined networking, slicing, function virtualization concepts. Then you will see it. General Electric Predix was introduced in January 2006. It used the platform as a service model and is cloud-based operating system and built on the so-called Cloud Foundry, and which is open source platform. You can put any applications you want in that platform. And also it's optimized for secure connectivity and analytics at scale. It's very important, data analytics in this concept. I will also mention this to you later. And so they take care of that. Cisco IoT Cloud is, again, it's sitting on 6 pillars. Network connectivity, fog computing or edge computing, data analytics, security. You know, security is the biggest problem, or one of maybe the biggest. Management automation and application enablement. IBM Watson case, it's again based on Cloud Foundry. And OpenStack, it's always open architecture, right? Software, open software. And Watson IoT platform development, it connects all the sensors to cloud application using so-called IBM Blue Mix. And then the PTC Things works. It is capturing 27% of the market. It has 3 pillars: core application enablement, connection service with device and cloud adapters, and edge connectivity using the edge microserver and edge always on devices, which is going to edge computing and fog computing. So these are the platforms that you may use. And I will not go all the details about applications. You know, smart home, you can see here like electricity control, air conditioner control, anything you can imagine for safety. Then healthcare, this was also discussed today partly. So here is the, healthcare has a lot of money, by the way. But you know, I explained yesterday, as Tunisian IoT or IT technology, you cannot compete with the Huawei or Europeans and Americans. So what you need to do is you have to focus on, for example, Arabic market. There are 600 million people. So tailor everything to this domain so that you can make maybe money. So here you can see here, it's expected from $32 billion in 15 to 163 billions by 2020. So these are the predictions in the healthcare. Transportation is also important for safety, efficiency, and sustainability. It will save lives and properties, reduce emissions, meaning protect environments, and also cut commuting time and efforts, as well as fuel consumptions, right? So it will also reduce our expenses. So you see also the cars will, they already have many sensors, but they will be built, they will have tons of sensors, plus there will be 1 million lines of code in some of these cars for the car-to-car communication, car-to-backbone, like I'm talking about vehicular communication systems, right? So now intelligent transportation, it will also help us like driver warning, autopiloting, etc. So smart grid is very important. So there will be a use for these. Here is a smart grid market from China. From total $20 billion, we are talking about jump to the $2 billion with alone smart meters. So smart meters is part of smart grid, as you can imagine. So now let's talk about what are the trends spending for IoT solutions, okay? So worldwide, these are really brand new results, by the way, information. There is still this noise in the back, please. Good that I'm not in the theater, an actor, you know, I will be always, anyhow. So worldwide IoT market will grow from 655 billions in 2014 to 1.7 trillion in 2020, with a compound annual growth rate of 17%. IoT analytics market, data market, is estimated to grow again at compound annual growth rate at 27.5 to reach $16 billion by 2020. So we are talking about really big money here, right? Total service spending, service meaning consulting, right? Professional consulting, consumer connectivity services, or services, you can say that. It will reach $482 billion by 2020. And IoT market in manufacturing operations will grow from 42 in 2013 to almost $100 billion in 2018. So global spending on retail and IoT initiatives is expected to grow to 15 billion in 2015 and 35 billion in 2020. Okay. So here is this again the IoT connectivity competitive landscape. So we have these extremely low data rate and higher data rates and very low distances, as you see here. But then these are all known to us, Bluetooth and Zigbee 802.15.4, and then 802.11ah. So they have reasonable medium distances and also reasonable data rates. But we are also talking about long range, wide area networks like LoRa. 3GPP is talking about for 5G developments, and then 5GPP will take over. Like Sigfox, these are the existing solutions, but many problems. I have to warn you also. When these people come out with, if they're company people, please accept my apology after 35 years in this business. They tell you the world, promise everything, but then when you get in, then you say, oh my God, there are a lot of things. And then they come in the version 2.0 will take care of that. I mean, that's the business. Yeah? They need to make money. Nothing's wrong with it. So 3GPP standardization for IoT, they are talking about category M device for LTE. Then also this is hot topic, narrowband IoTs, and also extended coverage GSM. So now you can see this is the picture for, this is today, LTE Advanced or LTE Advanced. This is more like we are trying to improve performance and mobility. And we will also try to, in the future, to reduce the complexity and also power consumption, plus extend the distances, coverage areas, and also accordingly capture more applications. So what are the major obstacles, right? This is still not $1 billion. I mean, you saw the numbers, but sometimes they're also elevated, okay? So don't take that exact numbers. So that's business world. Imad may know that, okay. So here, major obstacles for IoT deployments. High costs of, by the way, these are the priority list, okay? The top one are the highest priority, and then it goes lower to the lower priorities. High costs of required investment in IoT infrastructures. Concerns about security, privacy. Lack of senior management knowledge and commitment. Weaknesses in organizations' technology infrastructure. By the way, these are worldwide, not just, USA. Regulations, like standardization, that's one part, relating data privacy, but there are many other regulation problems. Weaknesses in public communication infrastructure available to organization. Immaturity of industry standard around the IoT, general economic uncertainty, undeveloped consumer awareness. That's really important. You have to understand what consumers need. That's why I also mentioned yesterday, you have to find out what is the Arabic world needing, and we can develop that here in this country. Absence of business case and business models. Okay. So what measure the company is taking to use the IoT more extensively in the business? Again, highest priority going to the lowest priority, okay? Seeking advice from third-party experts and consultants. Learning from the successes or failures of early movers. Training existing staff to work with the IoT. Conducting or sponsoring research to establish market size and demand. Establishing a cross-functional task force to explore and or pursue IoT opportunities. Introducing new business models. Raising fresh capital to explore IoT options. You need investors, right? Also, sponsors. Hiring talent with IoT capabilities. Many universities still don't teach these, IoT per se. Establishing joint ventures or alliances to exploit IoT opportunities. Establishing an IoT center of excellence, not just one. You can do that here too, for example. Center of excellence in IoT in Tunisia. Acquiring a business or assets with IoT capabilities. So, these are the business versions. What are the things, trends to watch in the future? You can also become a service company or IoT. It's called IoT services, business consulting. That's major driver. You don't need to always have infrastructure and deploy everything, right? That will be a good market for a lot of people. Then, data, so much data will be collected. We need to find out the most efficient, optimum data analytics solutions. Because data must be managed, filtered out, integrated, analyzed, and then we need to make sense of this collected information. And IoT is really getting more and more into this cloud and softwareization. So we need to also find ways of doing that. And also, IoT data, there will be a new market as data brokers. So that could be another business model. That means IoT generated data, it can be collected and can be sold to other companies. As an example, IBM bought the weather company data. So that company did a lot of money through that, right? As a data broker. And there are interoperability problems. I will also mention this in the standardization problems. And of course, the most important one is the security. So this is not the prioritized, by the way. So the security is the last one, but the most important one. So research challenges, we have so many papers on sensors and RFIDs and, you name them, 300, 400,000 papers. You cannot use almost any of them, really, because they are not scalable, all this routing and all these MAC protocols. So we need scalable solutions. How do we deal with the massive number of devices? Not only massive, but also heterogeneous, right? Security, privacy, Vint just mentioned about this. Safety, authentication, denial of service attacks to those devices. Interoperability again. Again, how do we handle the data that we will be collecting of these billions of devices, right? So, we need gigantic data centers. Maybe before they come, we will filter them out, calibrate them, aggregate, fuse the similar data, and then get them into these data centers. Reliable coverage. I mean, good luck with the utility companies. 2004 until 7, I had work for Smart Grid. They are extremely conservative. They will not apply wireless communication because they say, I cannot trust my substations for some 1% or 0.5% failure, because it's like death situation sometimes, right? So, we need reliable coverage if you want to do wireless. Move cloud services to the edge of the network, fog computing. Reduce data to be stored. That's another, finding better storage techniques or processing capabilities. Power consumption problem, energy harvesting, software optimization or softwareization, and SDN and FE-based IoT. And, So I just mentioned to you SDN and FE. In case you never heard of it and you are still in networking communications, please get there, really. So, because you will see 100,000 papers again in the next 5 years. So most of the research was done for the wired networks the last 10 years. So the idea is take, just simple idea without looking at the figure. The idea is take the entire software from the switches, put them to cloud or so-called controllers. Please do not mix controllers with the clouds. So the controllers are devices. For example, Huawei, Cisco, Intel, they all produce controllers. They're pretty expensive, by the way. So they have basic software, but then it's an open architecture. You can develop your own software or purchase other software and put it up there. So that's the open architecture. It really supports innovation. So that's the beauty of these controllers. But there are so many problems because the controllers, or one controller or multiple, they will be the brain of this entire network. The underlying switches will not have anything, just bare bone hardware. So the brain will always tell, do this, do that. So there's a lot of signaling between the controllers and the switches. And now we are moving to the 5G. All the base stations will be called remote heads or remote radio heads. Same thing, all the software from the base stations will be moved. We call them baseband servers, like data centers, as you see here. So all the software will be here, again, open architecture, and they will be coordinating these base stations because they don't have anything to coordinate. So these are the sub-brains. This is the upper brain. This is the backbone, brains. This is the backbone here in this back. So, and then, now we are coming to the IoT, right? IoTs will have the same thing. So, by the way, these are all under development now, so the concepts. So you can have another third level of controllers here. Again, pull out all the software from the sensors because they need a lot of energy, right? Energy consumption. And then also they will be simple, just simple hardware. And actually you can do that, right? So these software will be sitting in these subcontrollers, and then the subcontrollers will tell to sensors what to do. And by this way, you can also solve the scalability problem. But again, please, we have a paper on this 5G challenges, so you can read a lot of details about this. This is a brand new thing, as I told you. So everybody was looking at the backbone. Now the 5G people start to look at the base stations. There are very, very few people looking at the IoT domain. So I hope I could give you some ideas. Then more challenges, standardization, interoperability is really a big problem, right? And also when you use cloud-based software, SDN-based systems, you cannot wipe out the legacy systems. They have to work together, right? So how will we do it? And you can say, oh, we'll just put a gateway. That doesn't solve the problem, right? So heterogeneity of sensors and interfaces to cloud servers. Again, the standardization is not there. Like 802.15.4, Zigbee, it's a joke, really. I mean, when you know the subject, they are having these simple-minded tree architectures, simple-minded number of devices. So we really need a standardization body which can help this, IoT problems. Oops. I think that's it. Thank you.
Thank you very much, dear Ian. It's a very amazing presentation. I guess that there is a lot of questions, but we can select some of them. Yeah.
Each question costs $3,
Actually, I have two questions. The first is about connectivity.
My eyes are bad off. I hope you're not handicapped. It happens to me sometimes you make mistakes in life. So there was a student in my class. He had headphones. So I was really upset. I said, what is this? Get it out. He said, Professor, I have tinnitus. You know what tinnitus means? And I apologized 10 times, So it can happen. Maybe you're handicapped, you couldn't get up, right? So, sorry.
The question about connectivity, or will 5G solve all the problems we have today with interoperability? The second question is about
First question about interoperability.
will 5G solve all these problems? We have a lot of technologies like LoRa and other technologies for communication.
Shall I answer it now?
Second
Okay.
question:
Yeah, go ahead.
can we use the open technologies we have today to use with the web to create a much larger network that will help integrate machines into the network? Thank you.
Okay, so I can go backwards, right? There are also web-based IoTs, as you know, right? So that's another track I didn't mention here. Web-based IoTs. It's all really mostly like software-driven IoT. So it goes that same direction. So that's why I mentioned to you, this will definitely help us to solve some of these problems like scalability, interoperability problems. The first question, it's not like 5G will come, boom, everything will be solved. So there are all these objectives for 5G, ultra-high data rates, much better coverage, green communication, M2M, all of that, right, IoT. So it really depends on you, younger people and researchers, to attack those problems and solve them. So if we can solve them, that's great. That's the objective, right? So I believe that we will solve them, but we need also people like you, young people. And at this point, I want to also tell you what I mentioned yesterday. Please try to find original problems. Do not go and take his problem and then write extensions. That's not a good research. That's not a research. It's just waste of time. So if you want to be having impact, not only for your own career, but also for the technology advancement, you must find some original work. I mean, there are many original problems there. I just showed you some. You can find more, and then don't be scared. You say, oh, it's too much, I cannot do it. That's the challenge, my friend. You invest, you risk, but then the return is very high for you and for the advancement of the technology, right? So, yes. We have only one.
Thank you for your presentation, sir. We have talking about IoT since 8 years. But till now, there is no product for IoT. IoT is still only in big companies like Cisco, Bosch, and other companies. Until when we will talk about IoT? And what is the purpose for big company about IoT? It's prototyping products or being data companies. Thank you.
Okay, so it shows that you are still a young fellow. IoT is on the market since 20 years now. So 1999, 1998, we started to talk about it. You know why is this problem? Because of the pressure of how we can make fast money for the business people and researchers. How can we find easy PhDs and getting solutions? So that was one of the problems that IoT dragged and dragged. Everybody focused on sensor networks. 300,000 papers have been written. Assumptions after assumptions. They didn't care about applications. So here's another example. So-called MANETs, right? Mobile ad hoc networks. There are maybe some of you, I'm sure, wrote papers on them. What are the applications? What is the business model? Mostly it was used for the military. Now we start talking about, can we use them for the VANETs, right? The vehicle ad hoc networks. But then there is a new area. People are writing more papers, mostly useless. Sorry about it. I mean, I'm one of them too, by the way. No. Anyhow, so that's the reason. That's why I told them, advancement of the technology. So as an example, you should really start from the application perspective. I told you what is needed in the Arab world, define the applications, and then come back and develop the technology. What is needed? How do I solve the data analytics problem? How do I solve the scalability problem? How do I solve security? Well, what you do is in the universities, here's a security key management. Is it working? I don't know. I just simulated with MATLAB, it works. That's the reason. So, coming back to your other case, So now with all the softwareization ideas, now the companies, they're not making money. I mean, all these numbers are really optimistic. So, yeah, really. So they are creating these platforms hoping, because if the wildfire catches, then it will be gigantic, like billions of dollars of business. But it's not. So it's all depend on us how we can make this a multi-billion-dollar industry. I can assure you that all the IoT companies, including Bosch people, whatever, they are not making gigantic amount of money. They are hoping to make money. It's kind of investing. I mean, selling to some companies or some universities, that doesn't cut it. We are talking about billions of dollars, right? Plus, they have Huawei in the back. Don't forget that. So whatever Bosch or Ericsson, Intel offers, they come with 50% less. And I know Huawei because I work with the headquarters very closely. They're not making IoT money yet, but they're coming. Okay? So I hope you're answered.
Hi. So I would like to know if you have to choose between the four platform, Predix and Cisco or IBM or PTC, which one you're gonna work with, or or that depend of.
I just presented to you. You can decide yourselves, but I will not pay any money for them because I have a Huawei connection. Then. So we have different platforms. But, you know, you're welcome to look at that. Right? So I just present to you, they're existing. There are some others existing, but, you know, they are not that open now. Yes?
Okay. My question is related to security and privacy.
Yeah.
You are saying that technology should respond to the application need. Do you think that this is also the case of security? Or should we design generic security and privacy solution that would support all the applications surrounding the human or the object environment? Thank you.
Very good question. First of all, I don't say we should do security only on the application layer. Unless we do this SDN and FV, of course it must be there because the devices will be something dumb. What I believe is one size does not fit all. Take this word from me. If you develop generic solutions, I went through that with sensors. So we developed a lot of solutions also in my lab. And then Aramco came to me, Saudi Aramco. They said they want to do oil reservoir digging. You did all these underground sensors. Can you help us? Since 8 years we are struggling. I cannot use any, I mean, I can use the theoretical things, but so we are developing new hardware, new protocols, you know, all of the above. So that's why I'm saying, instead of, I mean, you can develop generic solutions, right? But what I recommend you is, for the big impact, is you determine some applications. Please do not try to compete with France or USA. I repeat this again. 600 million people are here in the Arabic world. And in my opinion, I mentioned yesterday, you are the most advanced one in IT technology. I'm not buttering you now, it's true, because I travel all of those countries. So you could use that, and you can be the leader in the IT technology, and then develop solutions for IT for those countries because they are Arabic-based. Like yesterday I mentioned again, Hajj, for example. In Saudi Arabia, I have center there in King Abdulaziz University. I'm traveling all the time. So they have not the manpower or the level that you have here. Like universities have projects, proposals to solve Hajj problems, but they need more. But don't say they will go to Americans. No, you can go and say, look, there are many Arabic-speaking Hajj people coming. So we will tailor all these things for their needs. Billion-dollar industry. You don't need more. I mean, I'm developing smart meters, so what? And then they will go to France or Bosch, they will get that from them. So, or Huawei, right? So that's what I'm saying. So please do that. So you are welcome. If you are a professor, of course, you need promotion, tenure. Students need PhDs, right? So this thing that I mentioned to you, application-driven impact, it takes longer. You need more patience. But if you say, look, I need my promotion, tenure, and I cannot wait 2 years to solve this problem, then write many generic papers. Who cares? And your people will look, oh, he has 20 papers, you get associate prof level. But what is the impact? Yeah, we'll see it. I mean, I'm not discouraging you. Please do that. But we are talking about like general solution now, what can be done, right, with the companies and university people. Or the senior people. You know, we have senior professors here, right? So you don't need to tenure promotion. And you can make this deal with your president saying, look, I'm starting Center of Excellence, get some people around, not only in that particular university, but across the Tunisia, plus companies involved. And then you start to advertise with your work and with your contributions. So I feel like I'm in mosque, like this Friday Wa'az, right? So I'm giving the Wa'az now. Is it Wa'az? Yeah. Yeah.
Thank you. Thank you for your presentation. My name is Najib Abid. I'm a CEO of a Science Park in Sfax. So my question will be about smart cities. So as a CEO of a science park in Tunisia, I know that our references is the Silicon Valley around Stanford University and the culture of entrepreneurship. And the key word was how to create the synergy between all of them. Today, there is a lot of initiative talking about smart cities. In Tunisia also, yesterday in the television, I saw something about Bizert, etc. My question is about smart cities. What is the first steps that we have to make done to attain the best solution in a small smart city? And is there any reference in USA about smart cities or in the world? The comments, your comments, please.
Yeah. Also good question. Smart cities is on the market since many, many years. You know, like 8 years ago in Barcelona, one guy came and said he wants to create a company for trash management, part of the smart city, right? So in the US now, there are some cities are claiming they're smart cities. Like one of them is Chattanooga, Tennessee. And Atlanta says, but you know, the larger cities are more difficult because, you know, all automatizing everything. So it's not, the train is not left the station, by the way. There are a lot of issues that you can do it here too. So please do not say, oh, smart cities are solved, we don't need it. It's a gigantic range of problems in smart cities. So coming to your, and by the way, there is also the new initiative from NSF, National Science Foundation in the USA, and with the Department of Energy and Defense. They are trying to create wireless platforms all over the United States. And, you know, we will go, I chose the University of Tennessee in Chattanooga with the mayor office to go for that because they have more chance because it's confined, right? So for you, my suggestion is you take one part of, I mean, this Tunis is unbelievably big, very large, right? So you take one part of Tunis or some other small town, and then you define what do we need to do for, you know, starting the smart city. So you again take a couple applications, like, smart meter. Just an example. I don't say that you have to do smart metering system or smart transportation system. Actually, somebody presented to me, actually a Professor Kamun student, they have this bus system, right? So they want to create, the buses are coming this time And so that's a part of a smart city also. They also went one step ahead and saying we want to also support disabled people like blind people. So there's already some steps already. So you can maybe talk to each other. If I will be in this country, what I will do is, yesterday I talked about it, but I can repeat. First, I will do top-down approach. So one person should volunteer and saying, this is our vision, guys, center of excellence in IoT. Then he will define sub-areas, like, you know, again, I repeat, just data analytics part, database people, right, machine learning people. Then here's the communication people. Here are the software engineering people. So having all these bases covered with leaders. Of course, not only university, but company people should also be involved. It should be two-way street. Again, I mentioned yesterday, if I come to you and say, let's work together, then you will ask me, what is in it for me, right? And I say, oh, you will have papers, and you say, I don't care about papers. So it's all about money, right? So then the money must be created. With the vision, you go to the government or to, you know, I don't know, defense or city mayor or all that. And some companies make some investments because they may sell that, say, product or system, say, to Algeria or to some other countries, right? So that will be for them the payback. So that will be, you know, my view. If I were here, I will push that direction. And again, some people will be outliers, meaning, oh, I don't want to involve. Who cares? Then don't involve them. So you have enough people, critical mass, that you can do it. You know, I don't want to put burden on Farouk Kamun, but he will be perfect person because the leader must also have the respect of all the other people, right? Because, you know, if the guy doesn't have that respect, and they will not look how quiet they are now, you see? So that's what I would suggest. I don't know if he'll do, but maybe somebody else. Okay? Maybe Imad can do it, huh?
So thank you very much for your... it's very clear that we have a lot of works to do, and mainly, as we know, in Tunisia we have a lot of, actually we have a lot of doctors without jobs in biology and physics. So this is the opportunity that they can find something to do and to work in a very interesting field of studies. Thank you very much, Dirian. So now it's our pleasure to present our second speaker, Professor Muhammad Hamdi. He's at home in Subcom and El Ghazala Technopark. He published more than 130 research papers, editor of mathematical theories for computer and network security engineering book. He's the head of Department of the Development Communication and International Cooperation in El Ghazala Technopark, and keynote speakers in several very known conferences worldwide. So thank you for accepting our invitation. So this is your slides. So we have 20 minutes. That's
okay.
good.
Thank you, Professor Kamoun, for the introduction. I also thank you. I also thank the organizers for giving me the opportunity to participate in this very interesting event. So my presentation will be about highlighting and pointing out the challenges and the trends related to security and privacy in this new context of IoT. I will begin by showing you this slide illustrating how the internet was architected in the very early phase in the DARPA in the US. And you see that it is a very simple architecture. But now, some decades later, look at the connectivity graph illustrating how the terminals, servers, hosts, all of these components are interconnected throughout the internet. So the complexity of the internet is growing exponentially. And this also illustrates how, in terms of the protocol stack, the internet has evolved. First, there was a big concentration of protocols at the application layer, at the physical layer, but all of them went through the IP protocol. This was the heart and the core component of the internet. But now, after certain decades, we have some busy and a bottleneck, a sort of bottleneck in the central part of the internet. And this completely transforms the shape of the internet. So this traditional 7-layer model, it is very well adapted to client servers, 2-tier, 3-tier, N-tier architecture, but not adapted to the context where smart things that can be cars, RFIDs, smartphone, robots, when all of these become connected to the internet, and more precisely, when they become autonomous in terms of decision making, the 7-layer architecture is no longer compatible. That's why several models have been proposed in order to represent how the Internet of Things should look like. Of course, multiple models, 4-layer, 6, 5. This is one of the models. It is the most detailed one, but not necessarily the most popular. And you see that in addition to the traditional, to the traditional layers of the internet, we have here a layer for the physical devices and controllers. And as I pointed out earlier in the presentation, the new thing here is that they will become autonomous from their connection to the internet. So they are connected, they can collect data, they upload data on the internet, but also they communicate with other objects. So these will also be able to connect in machine-to-machine scenarios. So we will have new scenarios that will connect these things, the traditional encapsulation, decapsulation, but also the M2M that will bring new opportunities and new challenges. We have some layers in charge of aggregating the data, in charge of pre-processing the data before sending on the internet in order to optimize the use of the bandwidth resources offered by the different kinds of gateways. And also, third very important part, it is how to process the data, because the data will be big in terms of volume, but also characterized by a high velocity and a high variety and a high heterogeneity, stemming from the fact that we will interconnect different things, different applications to the same ecosystem. As an extension to this thought, some analysts try to illustrate the evolution of the internet. And one of the questions that was raised in an interesting article published in 2016 is if the internet was a country or an economy. The answer is that it would rank 5th in the world in terms of GDP, in terms of gross domestic product. So this tells you about the volume of business created around the internet. But I extend myself this reasoning and I bring another question. What if instead of using the GDP, we use 2 other indicators, the net national product and the gross national product? What's the difference between GDP and NNP and GNP? And what do these indicators have in relation with technology? The answer is that GDP is mainly related to geographic region. It is the border of the country, the GDP of the country. Unlike the 2 other indicators that are related to citizenship. So they take into account in the traditional economy, they take into account offshore companies, for example, that are not geographically in your area, but they are creating animation of the economy of your country. In traditional economy, there is a difference, but when speaking about the internet, which is natively cross-border, a cross-border network and an international network, how can we deal about these or the extension of this reasoning from GDP to GNP and NNP. And the second question, which is more related to the Internet of Things, is how the notion of citizenship will be represented when we will speak not about humans, but objects. My car that will create business, for example, by selling or by uploading the data from the GPS to other applications in order to create added value that will be sold to a company. These are new business models, and the notion of citizenship, when speaking about object, is new in terms of technology, of course, but also in terms of legal and jurisdictional aspects. So the evolution from the Internet to the Internet of Things is creating very new challenges, are very interesting opportunities to look at. These challenges are represented here. So these are not the security challenges, but some of the challenges related to the evolution from the Internet to the Internet of Things. First one is scalability, how to deal with this exponential growth of things, of the scope of the application, of the diversity of the application. All of these are growing at a very big pace, and the evolution of the technology is not necessarily following the evolution of the needs and the evolution of the concrete world. Also, discovery. Discovery is very important because at the physical layer, if you remember one of the foregoing slides, at the physical layer, one of the tasks of the object will be not only to communicate, but also to gather data and to discover the environment. And since the object will be autonomous in terms of decision, this autonomy has to be in conjunction with context awareness. So the object has to act and react and to decide in terms of, or in accordance to the evolution of the context, of the dynamic context. It can be temperature, it can be physical location, it can be time. So all of these are part of the dynamic context, and the object has first, before doing the processing, it has to discover. One of the problems is how to do discovery, especially if the objects are deployed in a non-trusted or in a non-secure area. So this becomes a very big challenge. Third one is performance. Performance stems from the heterogeneity of the objects. These can be, as I told you, cars, robots, very tiny sensors. And this heterogeneity makes that the algorithms that will be developed on these objects have to adapt to the resource in terms of CPU, memory, storage of the objects. So we have generally now asymmetric models between the infinite growth of the resource in the Internet, especially with the growing of quantum computing. And last year, the first quantum computer, completely quantum computer was devised in a laboratory environment. So these things are coming. So there will be some infinite resources in terms of storage, CPU, and memory at the core side. But our objects are very resource impoverished in comparison to this core component. So one of the problems is how to deal with this asymmetric distribution and unfair distribution of performance. Also, the harmonization of standards, and Professor Jan already pointed out the importance of standardizing the different components of the Internet of Things. And last one is big data. And data is very important now from the economic point of view, because it's creating some new economic and new business models that did not exist before, especially the data brokering mechanism. And the fact of dealing efficiently with the data and extracting relevant information from the data is very, very important, because the volume of the data, its variety and its velocity will prevent existing mechanisms in terms of data science from doing the right job with respect to these requirements. Now I come to the security challenges that I will highlight. I will begin by saying that the advent of the Internet of Things is creating a nice ecosystem for the attacks to flourish. So it will create very significant challenges for people who are working in industry or research in the security area. And this is to tell you that the Internet of Things cannot be thought of separately from a complete landscape in which we find, in addition to the Internet of Things, cloud computing, social networks, and big data in terms of research niches. Why? Because, for example, if you look at social networks, their interaction with the Internet of Things is that they can create new interaction models between the objects. So there are new social models that are unlike the traditional models using on the Internet, the client server and these similar models. Now we have the communities, and we can speak about communities of objects that will create new attack vectors. And last year in 2016, there was two very big distributed denial of service attacks against hosting companies in France and in the US. And according to some analysts, the bandwidth of these denial of service attacks exceeded for the first time 1 terabyte per second. So imagine the volume of the data. It's very big. How can we reach this volume of data to attack a single infrastructure? The answer is that they used the connection of some things. In this context, they were surveillance cameras that which can upload very huge volume of data in order to attack the victim. So these new types of connection in terms of social network between the connected object can be used as a vector in order to accelerate or in order to amplify the impact of attacks, including, for example, denial of service attacks. Some other challenges related to the IoT itself is that multiple objects don't have even an IP address. They just have a pseudonym. And the way to connect or to interact with this object is not easy, because many of the identification, authentication, confidentiality protocols used on the Internet rely on the IP address. So it will be difficult to incorporate or to integrate objects that are not identified as supposed by the Internet protocols in the Internet ecosystem. I already highlighted that. Also, it's very important to know that in the Internet of Things, there will be very important variation in terms of dynamic context, in terms of time and space. This one is very important, risk sharing. It's brought by cloud computing, because some part of security is about identification, analysis, and assessment of the risk. Before taking the decision and before implementing the decision, I should know the risk taking from the existence of the attack or from the existence of the vulnerability, and then I choose the right countermeasure according to the level of risk. But unlike traditional information systems, in cloud computing, the cloud provider shares the risk with other parties, including the owner of the data, the host or the hosting company, the developer. So all of these actors are sharing the risk, and these are new models in order to integrate how to take the decision about which security solution or which security countermeasure is better for a specific context. In terms of big data, the challenges are basically related to the complexity of the cryptographic routine. For example, if you have a very huge database and you want to scroll across this database in order to execute a basic query. And imagine that this database is encrypted, is fully encrypted because of privacy concerns. The question is, if in order to execute the query, of course, I cannot execute it roughly on the encrypted data. I have to decrypt first, look for the correct output, and then re-encrypt. If this database is about millions of lines, this will take a huge time, and this is not good in terms of performance. That's why some new models are considered here. for example, homomorphic encryption, identity-based encryption, all of these are being investigated in order to solve how to deal with the complexity of cryptography when dealing with big data. This is in addition to the multiple processing needs. There are new needs, for example, aggregation of the data, search, and the new scenarios that we can execute in order to extract, as I told you, information from the data, which is not easy in terms of data science. So in terms of traditional life cycle of the data, generally we have these 7 phases, beginning from the generation, the use of the data, then the transmission or the transfer of the data, transformation, if needed, storage, archival, and destruction. This is generally the life cycle of the data from the generation of the data to the destruction. Of course, this depends on the application, and the list is not necessarily exhaustive. It depends on your needs and on your requirements. Some question here is when we will extend this life cycle to the IoT, to the context where the objects will be connected, not only the terminal, the client, and the servers. First one is where to store the data, because now I don't have only the servers that are able to store, but also even the objects have some storage, some small storage capabilities. So how to distribute the storage capabilities across this new scheme and across these new layers and this new architecture of the Internet of Things. Second one is about retention, especially in communication. There is a need for retention of the data. Retention is that I have to satisfy that the data should be available, for example, 1 week or 1 month. It depends on the need. And retention, generally, it is conditioned by some legislation or by some regulation, meaning that by the law, I should preserve the data for a certain period of time. The problem is, since the network will be very distributed, and since the scope of the network will be very wide, retention will become a big concern. Destruction also, auditing, monitoring, and risk management, because we don't know how to audit or how to analyze the risks in a very distributed environment, including different kind of objects, and especially with new business models and the new threat models. Privacy breaches are very important in the Internet of Things because they can originate from multiple parties. Traditionally, privacy, it is related to the privacy of human. It's my data. But we can also extend this thought to speak about the privacy of the data of the object. So the object itself will have some private data. And the big question here is who will be responsible for protecting the privacy? Which actors can we implement in order to protect the privacy of all of these data? 2 minutes. I will skip over this. So I will finish by highlighting some open problems so that people can, that interesting people can identify some niches to work on. A very important problem is privacy versus lawful interception. Lawful interception is a very interesting functionality especially for telecommunication operators. And even from the legislation point of view, it is part of the Budapest Convention. This is the capability of the law authority or the law enforcement authority to extract data from an ongoing communication. So it is lawful interception. It is the capability to intercept the communication. Of course, under a very strict scope in terms of time and space. So this is, for example, a way to implement lawful interception in the context of 3G and 4G networks. But in the Internet of Things, different schemes will be possible to communicate between the objects. M2M, which does not go through the 3G and 4G. For example, we can have specific gateways, including LoRa, Sigfox, and these schemes. We can also have voice over IP, which is not covered by this technical scheme for lawful interception. And the problem becomes more complicated when the context requires the anonymity of the object. For example, in medical application, sometimes we require that the data stemming or originating from the object is anonymized. And in this context, we cannot identify or we cannot do this intrusion, this benign intrusion or this lawful interception in the channel. The second important channel is anonymity versus authentication. For example, one of the very popular tools for anonymity is onion routing. This is the nested routes that prevent, for example, censorship equipment to prevent you from reaching a certain destination, or that also prevent some authorities to identify your identity or your location or something related to who you are. So the problem here is how to combine these two requirements, anonymity and authentication. Authentication is to prove who you are, and anonymity is to hide who you are. In some situations, we are in an obligation to fulfill both of these requirements, and we need new, not only cryptographic algorithms, but also new trust models that are different from the existing models based on PKI, PGP, and the similar models. So we need new trust models in order to implement new security functionalities in the IoT. I will finish with this slide, which presents the very important technical challenge also: federated identities, anonymity, and privacy. Federated identities is when you have multiple identities going through a signal, through a single authorization channel. So you have multiple identities, for example, one password for YouTube, the other one for Facebook, but since you are logged in one application, you are automatically logged in the other application. So your identities will be federated into a single identity using, for example, a signal sign-on mechanism. Now we have some solutions for the traditional model of the internet. But what if, for example, my identities will not be passwords, but will be the identities of the objects connected to me? There will be the identity of my car, of my laptop, of my smartphone. I want to combine all of these in order to have the same profile according to some applications or according to some portals or whatever. The issue is that the operating system will not be the same on all of these environment, and also the computational resources will not be the same. So this is a very important technical challenges that you can address in order to fulfill some significant results. So thank you for your attention. I hope that you enjoyed the presentation.
Thank you very much for your very technical presentations. So we are expecting some questions. Who will be the first?
Hello, thanks for your presentation. I present myself. I'm Iman Abdelli. I'm a student in management. I don't know about programming, neither informatics, but I have a business model for intelligent cities, which has the problem about identification and which makes different services, like for managing garbage and managing security for some city. Okay, so how, what are the advices that you can give? I don't know how to program. So I go for an enterprise to manage the project, or I go for a programmer. I hire a program. What?
The answer depends on your expectations in terms of time, in terms of timeline. If you want to go fast, the best way is to define a good business model, a good business plan, and then to hire the good people and the right skills in order to fulfill your objectives. But if you are rather going into a research trend, you have time in order to investigate some technical issues, even when you mix them with managerial aspects. This is very good in terms of research and development, applied research. But if you have the pressure of fulfilling some business needs, you don't have time to go through this channel. So it depends on your needs.
Other questions? Yeah.
Thank you. Thank you for your very interesting and up-to-date presentation. So my question is about data life cycle and mainly about the final phase, which is destruction. So as you know, actually we speak a lot about, in French we say, we speak about le droit à l'oubli, which means that data is never destructed. If the user sends a request to destruct the data, it's still saved somewhere in the network. So maybe could we speak about logical destruction and not physical, which means that some cryptographic or some mechanism should be applied to the data which makes it unuseful. So what do you think about this issue? Thank you.
Thank you. In fact, the real challenge and the more significant challenge with respect to this aspect is not only how to destroy the data, but how to verify that your data is destroyed. So it is the opposite way. Because destruction, there are some ways in order to archive, in order to preserve and to do all of this stuff. This will not change a lot in terms of shape. But the most important now, since different actors will be involved, for example, your cloud provider, the data broker, and so on. So your data, even if it is private, it will be communicated to some parties. And with these parties, you establish some trust relationship through SLAs and through other mechanisms. And the question here is not how to destroy the data, but once you issue this request to destroy your data, how can you verify that the data was effectively destructed? This is very difficult in terms of proof, because there is a proof of ownership, there is a proof of authorization, all of these proofs, but the proof of destruction is still very rarely investigated in terms of research and development. This is the question.
If there are the last questions, yeah.
Thank you for your representation. My question is about the slide of about anonymity and authentication. I didn't get very clear the compromise between those two. Are they related to security or routing data in the network? And what's best if we want to think about solutions in? I'm working on wireless sensor network, so in routing specifically. So maybe I will get into security problems. So these two terms, what's best to attack more than the other? So if you can explain more these two, thank you.
Authentication is basically about proving who you are. Identification is just saying who you are. For example, my name is Mohammed, but authentication is the fact that I give you a credential proving that I effectively hold this identity. But anonymity is about hiding my identity. Of course, in a certain scope, not because we can never hide the identity in an infinite scope. And in some contexts, for example, voting, or for example, fleet management, we need from the object that the object is authenticated in order to prove that this data effectively comes from, for example, my car or my television or my smartphone. But in parallel, I need to anonymize the data so that intruders or people who will attack the database will not be able to identify or to violate the privacy of my data. When we need to fulfill both of these requirements simultaneously, the traditional security mechanisms, or at least most of them, do not allow, because the requirements are clearly in conflict, proving who you are and hiding your identity. So it's not easy. There are some mechanisms, and they are basically relying on some new trust models. Not the PKI, not PGP, not asymmetric, symmetric, but new mechanisms including identity-based encryption, for example, threshold cryptography. These are the niches and these are the techniques you can use in this context.
Yes. Thank you. I want to ask is it benefit to make blockchain technology and IoT, and how blockchain technologies could improve IoT applications and services, including IoT devices, process, and data. Thank you.
Thank you. That's a very good question. In fact, blockchain is one of the technologies that can be used or that are well adapted to the philosophy of the IoT because they are adapted to this new architecture which is flexible in terms of distribution of power in terms of resources, for example, computational resources, etc. And these chained cryptographic mechanisms also adapt to the requirement or to the challenge I mentioned, which is the new social models, different from the point-to-point, from client-server, or from the traditional routes. So blockchain is a very important technology or a very important paradigm that will probably have a big, that will be a driver of the security and the Internet of Things.
So thank you very much.
Thank you.
Thank you, Professor Mohammed. Now it's time to the third presentation and the last one is our Tunisian talents abroad. Working in Qatar. So Fathi Filali is the head of technology development and applied research in Qatar Mobility Innovation Center, and he was associate professor in France 8 years ago, received 15 funding grants. He have more than 130 research papers, 10 patents, internationals, not Tunisians, and he invented technologies and developed algorithms that have been achieved in many QMIC products, including Masarak, Labib, and Wavetraf. Thank you for coming with us and coming back to Tunisia.
Thanks so much. It's always a pleasure to be in Tunisia and try to give back small of what we have learned in Tunisia for 25 years ago. So this is really a pleasure, and I tried myself to keep touch with people with universities and districts and colleagues and hire some of them. So basically in QMIC we have a good number of Tunisian talents working with us, and some of them are really behind what we are going to discover today. I'm really sorry to be with between you and the lunch, so we don't have a lot of time really to cover all the aspects. I'll do my best to give you some insights. It's a really application focused presentation. I'm not going to talk about technology because I'm sure that all of you, they know the technology now, we are aware of what's going on, but to make an impact, again to what Jan said, to make an impact we need to be application focused, and we need to show to the end user the great value of the applications and service that we're planning to deliver. Just for some of you who does not know maybe QMIC in a nutshell, QMIC is kind of an IoT excellence, center of excellence in Qatar. So we are not using this term, but I like it. It was created in 2009, basically between a kind of joint venture between Qatar University and Qatar Foundation, and focusing in really in knowledge-based economy. We are now around 60 people. Actually, we grew from 1 to 75, and then a little bit down to 65 people or 60 people. So as an R&D focus is trying to focus on the market. We are not really research institutions. So we do R&D, but at the same time we try to do product development. It's user-centric. It's very important to engage the user, the end user from day one, to get the requirements from the end user. So we have seen a lot of smart projects and ideas, but you need to involve get your requirements from the end user. As technologists or IT, we may develop things which are very fantastic in terms of technology, but very useless in terms of the end user benefits, right? So it's very user focused, and we are working on a lot of stakeholders in Qatar, especially in big projects related to the metro, related to 2022 World Cup, related to smart logistics, and recently they launched what we call it the Qatar Smart Program under the brand name TESMO. Is a kind of smart nation program like in Singapore and Dubai and other cities, and hopefully we'll see some of these similar initiatives in Tunisia. So our mission is to to really to go from technology-based innovation to scalable digital businesses. And from day one, basically from 2009, of course, we are not reselling technologies. We are not reselling solutions in Qiomic. We started building the technology. We started building the algorithms, the sensors, the know-how, and data bank. Data is a gold mine. Data is very important in order really to provide the service to the end user. And after 2012, basically, so we got the seed funding from Qatar University, Qatar Foundation for only 5 years, 2009 to 2014, and we started rolling out products. So you see the M is new here. So we do market development. We do generate revenue from the solutions. So these solutions are branded like this Arabic names, all of them. So the focus is really the Qatar market, GCC, and maybe the MENA region. So these are verticals. These are not, most of them we started by verticals, but applications. We have seen a gap in transportation and mobility. We have seen a gap in air monitoring. So we developed 2 solutions. The first one is Masarak and Hawak, and another one about road safety. So all of them is about collecting data and then processing it and delivering the information. Then what we have seen is that we have a platform. We have a brain in these solutions. So we took out that brain and we built a new product. It's called Labib IoT, the IoT platform, right, which is application and device agnostic, and to enable others to build their own solutions and services. And recently we launched also Taslim is a crowd logistics platform and solution, is using Labib in the back end, but so Labib we started using Labib as well ourselves to develop a new solutions. So this is an on-demand delivery platform. Meanwhile, we are getting funds from what we call the Qatar National Research Fund to work in more research-oriented projects, and one of them connected vehicles. From 2009, actually we worked on this. In 2014, we did the first demonstration in MENA, and we are going to have a large-scale pilot by end of this year in Qatar. And we are building a consortium in Qatar around this activity. Just I'm going to, as in the title, there are 6 stories. So I'm going to talk you about some 6 stories that we had, and hopefully you can learn from them, you can get lessons from them, and you can apply them. So one of them is about our Masarak platform or Masarak solutions, an end-to-end solutions. It started by collecting the data, about building the intelligence inside to process that data and run the data through that life cycle. We are not destroying the data, we're keeping everything in our data center. We are talking about terabytes of data. And at the end of the day, we deliver applications, analytics, mobile application, and so on. So here, Masarak was developed in Qiomic. We are talking about 7 million lines of code. Most of it of Java. So we have a software development team, we have technology team, and we have, as a company, we have the business, the sales, the administration, finance, and so on and so forth. So we are running really as a company. So just to give you an idea about the data, we are collecting 1.4 billion of records just last year. So Qatar is very small. So we are talking about maybe grantees of population of 3 million, up to 3 million. So it's comparing. You can compare it with Tunis, Ariana, maybe Hammam Lamf, Benzart, and so on, right? So whatever we did there is most probably applied at the city level in Tunisia as well. So out of that, we, of course, to collect the data, we built our own sensor in-house, and we deployed that sensor in all these locations. We branded as WaveTraf, and to get millions of records every day. So because we don't have access to the data, the government will not. They don't have infrastructure in place to collect that data, so we had to do so. We had to come up with our infrastructure and get the approvals to deploy this sensor. So basically from this WaveTraf sensor, we get all the data and store it in our database and fuse the data because data heterogeneity is very challenging. So we are getting data from 3 data sources and fusing them. And this is some analytics that we are out of these billions of data, what we can get with the end user, especially cities. Cities that are very interested about congestion information, to do proper planning, to do traffic studies, and so on and so forth. So, for example, this is a heat map showing the traffic in 2015. We have 12 months, 24 hours, and you can see the traffic intensity, the congestion intensity, the peak hours, the impact of rain, the impact of celebrations, and so on and so forth. So from the data from one heat map, you can really get very useful insights. And you may wonder, what's that? This is what we call it OD matrix, is trips information. Is to know, for example, if you applied here, how many people are traveling from Iriana to Hammam Lamf, how many people are traveling from Tunis to Binzar to work there and get return back. So it's very important to know OD people movement in order to do proper planning, to decide to build a new expressway, highway, and so on and so forth. So this is online, this is available online. We have zones in Qatar, and we have the number of trips from this network. The network is collecting data, process that data, and we identify the trips, and we present them. And last year, actually, we started producing what you call it the Qatar Traffic Report to measure the impact of congestion about the. There is a problem with the text in Windows 8, but is 109 hours wasted by everyone in Qatar in the streets and the impact on the congestion. The second example is about the environment. So we are talking about verticals, right? So we are transportation, and then we move to environment. Nothing there is related to IoT. Everything is IoT, basically. IoT is not only using LoRa or using narrowband. IoT, you can start from now. Having IoT, we don't need really to wait. Right? You can use Wi-Fi, you can use GSM, you can use whatever to build IoT. IoT is a buzzword, just as a selling argument to say it's IoT. So we built our own sensors, and some of them are in collaboration with vendors, and we collect the data about the environment and weather, and we push that to the platform. Again, another platform, data and applications and analytics, but very specific for the environment. And we deployed this in the stadiums of Qatar. So stadiums that are under construction. So these are not real ones. They are still under construction. So we had the contract of millions of dollars with the FIFA 2022, and they asked us to deploy, because by mandate they need to monitor the weather conditions in the sites, right? Because this will impact the workers and laborers. So they need to be able to monitor that and then translate that to the action to stop, of course, from public perspective point of view, to present to the FIFA the reports, but also to make sure that if the heat index is very high, they ask laborers to stop working and get into the shadow and so on. So this is the station. This is the weather station that we built and deployed, and everything related to that in terms of sensor and in terms of platform, of course. So we are collecting all this data there, and we are delivering some insights to the end user. So then we said, okay, let's take that brain in the middle and try to build a new product. And this is the process that we followed to come up with Labib IoT in 2012-13. We started doing that basically, and we branded under Labib. I know Labib is very famous here in Tunisia, related to the environment, sustainability, and so on. But for some reason we use that term in our platform. So without really detailing, I think you know all the main blocks of whatever Labib IoT platform, in addition to Blue Mix or others. So you have the option to use Labib IoT for free. So in Labib it's very open, so you can connect whatever device, including LoRa, including Sigfox and others. And you have an IoT connectivity management. We have an analytics, the device management, and we can build all these solutions because we did it ourselves. We did it for the environment, we did it for transportation, and we did it for crowd logistics, and there are other use cases that you'll see later on for all different sectors. So basically it's about collecting the data, analyzing it, storing it, and trigger some actions. These are some of the latest features, because at the end of the day we want to generate money out of this, right? So it's not a kind of, we have the free plan, but also we have the paid plans. So we added capabilities in terms of billing, capability in terms of security, in terms of predictive maintenance. Predictive maintenance is very important, especially for industrial control system, to monitor them and so on. I'm not sure if we have in the audience people from SONAD, from this STEG, yes, from STEG and so on. So it's very useful as feature to whatever plants, basically. If you have machines there, we need to monitor them and monitor the lifetime of the site. Predictive maintenance, just I give more details here, is about monitoring all the assets that you have, connect them, and having access to dashboard to know the lifetime. To know when most probably the next time this asset or this machine will break down and you need really to replace it, or you need to be proactive instead of being reactive. And we have this capability already there. It's quite challenging to have one size that fits all. So basically you can't have one prediction algorithm or for all types of assets and machines. So that's why we are going through iterations to include different types of machines to this capability. So we have seen a lot of platforms, but we believe that we have competitive advantages regarding other platforms without going into details, and we have a guaranteed patent related to device management and malfunctioning detections. So in terms of device strategy, we added the capability in Labib to integrate open hardwares that are there. We provide the SDKs to connect them. So we are talking about, this is the big bulk of the device, but also if you have proprietary devices, we work with providers like Libelium. Now if you buy Libelium Meshelium, you will find the possibility to use the agent of Labib IoT. So we partner with vendor suppliers, and we develop our own agent, and this agent is integrated in their devices. So whoever going to buy devices from them, he will have the capability to use Labib IoT as a platform. So a kind of win-win partnership, because in IoT is very challenging to scale. And scaling can be done, especially for us in Qatar, can be done only through partnership. You cannot really go to the world with the technology developed in Qatar and say, okay, this is the technology developed in Qatar, please use it, and pay me money back. Okay, it's very challenging. So you need really to go through partnership and through partners to do that. And it's very good, because it's very win-win partnership. And here we are talking about hundreds of devices that could be supported using the Labib IoT platform. From communication and APIs, I promise I will not be too technical. These are the protocols that you can have in your device side and connect to Labib IoT. You are talking about MQTT, CoAP, HTTP, and if you have an IoT gateway with the right agent, it can be connected to the internet. From the application side, we have SDKs, Python, C, Java, Android, and others to build the applications. Because at the end of the day, we have seen some projects. This project, they don't need really to waste a lot of time in developing the platform and the database and manage their devices and so on. So they can either focus on the device side or focus on the application side to make sure that they can reduce the time to market and can deliver the end-to-end products. So it's faster time to market, as I said. Whatever IoT platform you use, basically studies show that you can reduce by 1 year the development. You have the source there. And some colleagues using, or some people starting using Labib IoT, they were able in 3 hours to connect their device and get access to the data. So I have a video. If you have a sound, we can maybe show you a video if you have time, otherwise. This video is to show that we need really to focus on the applications. So we have seen these are global challenges, not challenges in Qatar or in Tunisia or in France. These are global challenges. If you are not tackling a real problem, you can't really make it to the business, because if you are focused, you want to generate money. At the end of the day, you need to have valid business models, right? So can I get my laptop back? So it's not a marketing video. So please use the free plan of Labib IoT, and we'll be glad really to increase your plan for free if you need more data or more device to be connected. Right. So these are some use cases that we added to the Labib IoT. I think smart home is one of the top verticals that could be addressed, and we have seen some examples. And you can't have everything in the platform. You need to integrate with existing technologies, right? We did the integration with Amazon Alexa, Samsung SmartThings, and others, and very important to provide the end user with enablers and so on and so forth. The other point is smart industry. So industrial, usually they are not really, they are very strict to their protocols, their industrial process and so on. And most of these protocols are not IP compliant or IP basic. So it's very challenging sometimes to integrate with the SCADA, BACnet, Mobis, and so on. And so these are needed in order to be able to provide the smart industries applications. The other thing that we are working in heavily is smart city, and we have extra enablers that we developed ourselves to do that. And I'm not sure if you heard about Lusail City. Lusail is smart city in Qatar, is really under construction from zero. So now we are seeing a high-rising building, and we are working with them to use Labib IoT as smart city platform. There is a difference, big difference between IoT platform per se and smart city platform or city management platform. So we can have two different things. You can have the IoT platform to manage devices and data that feeds the smart city platform. Smart city platform is much bigger than that. It has access to citizens' identity, to GIS, to payment gateway, and to much more than that. So we are trying to work with them to give them the end-to-end solution in terms of platform, enablers, smart home, and central controller. So the last thing actually is about partnership. So recently we signed a partnership with Libelium. So if you go to the Libelium website, you can choose this kit where you have Labib IoT enabled and use Labib IoT if you have Libelium sensors. Also we signed many others with Intel, and some of them are not here recently, with the Red Hat and Microsoft, in addition to Smart Ants for LoRa, Libelium, Esprit, and think the engineering school in Sousse as well. So their students are using the IoT platform. These are real cases. So I want. We have seen the platform capabilities. Now you can discover some clients and customers with their consent. Basically, we are providing this information. One of them, this one is from Jordan. Jordan, we have a startup doing gas. You know, the bottle of gases, they have a level, right? So what about having a sensor there, stick to that gas bottle and monitor real-time the level and connect this information to logistics company, just providing this to the home, right? This is a good idea. And to do that, they don't care about the platforms. They want to use existing one. So they focus on the device side, and they use the Labib IoT platform to get the gas level and to do the dispatching. So this is a business case where the end user will pay for that. Your city will not pay for that. Okay, but the end user, if you have a mass of end users, you will get your revenue share immediately almost. The other use case in Qatar where we have And this is for smart farm is very similar to the greenhouse project, and there this is a real startup. Actually now they do sensor readings in greenhouses and also actions, and they send alerts and actions. So basically it's very hot in Qatar, so they use a lot of the greenhouse for the small amount of agriculture that they have. And actions, we are talking about turning the fans, try to increase the humidity, and do the smart irrigation, of course. So this is a startup. The other example is from Belgium. They have the Smart Ants company. They have a waste management application and use Labib really to complete the story, because they focus on the device side for the garbage level, and then they do the dispatching. The next one is from Italy. They use Labib IoT to get the consumption levels in meters. This is in Genova, and they send alerts on their existing control center, right? So once you have a platform, the impact can be global. So you can, if you have a solution, don't focus only on Tunisian, don't focus only on Arabic words. It can really go beyond that, right? So you can compete with others if you have the end-to-end solution, especially the cost structure here is very low comparing to others. So you can have your investments at the beginning is very low comparing to other countries. Right? Thank you so much. Sorry for taking so long. Hopefully that was useful for you, and we can.
It's really amazing. Yeah. I don't know if Labib is registered name in Tunisia, so all products will be for us. So, okay. Do you have some questions? Who be the first? Okay.
Hello, thank you, Professor Fileli, who was my supervisor in PhD. So welcome back to Tunisia first, and congratulations for all you are doing there. My question is mainly about the challenging issue of having this Labib platform, which is quite generic, and at the same time, I mean, we were advised to go through a specific application, but with Labib, you showed us that it was possible to do it for waste management, for environment, for other applications. So what was the main challenges you faced when you were building this platform? And is it, I mean, the difficulty is technology-wise or application-wise? I mean, it's because of the diversity of application that is challenging, or is it because you need to support different technologies like LoRa, Wi-Fi, and different technologies? And if it's possible to have just a small scenario, what is needed from the user as data, and what Labib IoT platform would, add? What is the part of each of them? The Labib platform and the user who would be using your platform. Thank you.
Yeah, thanks so much, Iqbal. Nice to see you again after some years. In an IoT platform, there are generic blocks, which we know of, right? About device management and data management, security, roles and permissions, databases, and so on. So we started with these basic ones. So basically, we have Masark already deployed in production. We have a lot of paying customers there. We took what is there in terms of software. We cleaned up. This is the process. We removed what is really related to the applications, and we kept only the brain, which we know of. We experimented. We know that's scalable. We have millions of records every day. It's very scalable. And then we added the IoT specific part, the MQTT, the co-op, the other functionalities which are very specific to IoT. And the most challenging part is to make sure that you have SDKs. You have SDKs in every language almost, because you have developers using C, C++, C#, Java, Android, and so on. So you cannot ask them to just write spend a lot of time writing the interface, the APIs. So we need to provide them the APIs to make it easy for them to develop their applications, but also from device side to connect it to the platform. And also for researchers, they need to be able to get the data only. They don't care about applications. They connect their devices and they want to get access to that data, make sure that data is secured, is stored, and so on. So we provide them with a web service. So we're using MATLAB in 2 lines of code. Believe me, in 2 lines of code in MATLAB, you can get the data. In Linux, you can get the data immediately. So this is the challenging part. Then, once you want to tackle verticals like healthcare and utilities and others, and industrial, you need specific components. And this is the next level of challenges as well. Right. So if you need more information, we can talk, of course.
Yeah.
Thanks.
Here, a question on the back.
Hello, everybody. Well, I'm Ignacio Castillo. I'm coming from Mexico. I'm with the
Who's speaking?
IEEE as DB speaker. I'm also involved in other things with an IEEE initiative. The name is Smart Cities, and I will be very interested in a way your company and your research group could be involved in a program in Guadalajara city. This is the second most important city in Mexico. They are trying to make not all the smart city. They specified more or less 5 square blocks inside the city in order to make a whole, as a mall, specifically as a smart city. So maybe your company could be related in that part of the continent. But my question is, how can you propose specific applications in a laboratory, in a real laboratory, trying to implement a smart city? How could be your contribution? Thank you.
Thanks so much. Smart cities, IEEE smart cities, I think Mr. Gilles, he's the president. Yeah, so I met him a couple of times and he had wonderful discussions, and we'll be happy really to contribute in the initiatives that we have. The second point regarding making an application laboratory, so if you have the capability to emulate devices or simulate devices, or you have everything in that laboratory, yes, you can prove the concept at least. But what we do, we run through 3 phases. We prove the concept, we pilot for free, and then we do commercialization aspects. So it's very important to run the 2 others, at least the pilot, on the ground pilot, in order to really to show to the end user the benefits. And this is what we did. We invest a lot of money and time in things that just we throw it, we put it on the shelf. So presents only the successful things, and maybe we failed in 80% of the things, right? So try and fail. This is never ends.
You know, I cannot hold myself. Normally, I should really don't say anything because you are a young fellow, very energetic, very ambitious, but you really became a businessman. Really. The way you explain things, you solved everything, and it's a wrong message. Number one, all those platforms I mentioned, from IoT, Cisco, etc., they're all based on cloud and controller. You have nothing to do with that concept because you are creating a middleware, and that will not work. And you kept saying you solve everything, and you cannot solve it that. I'm telling you, number one. Number two, yes. You said one size does not fit all. If you do cloud, then you have to have all this slicing. You don't have those things in your system even. Network function visualization, slicing, okay? Then you said, don't go to the Arabic world. Look, I saw how much, I'm scared to ask you because you will say I make billions of dollars now. How much money did you make giving to the Belgium? Did you say, look, can you try this? Or did you have hard cash? No. Be honest.
Very, very valid point.
No, but the thing is, my advice to you is, because there are a lot of young people, that's what they think, like, whoa, that's the way I should do it. No, So you should be a little bit more, conservative, tell the right things, and then you will get more credibility in the future, because some people will go and say, let me investigate, and they will find a lot of holes in this, and then you'll lose credibility. I'm serious. I don't want to upset you so that you will hate me for the rest of your life, but this is an advice from an older man, trust me. And also,
yes.
this is the thing. Since yesterday, I'm telling these people, no, look, I am in this business. I never heard of your Labib or whatever you call it. I'm serious. So you say, everybody uses Labib. It's not true. And so you have to be really more...
I did not, just to be frank.
From Qatar.
No, I did not
say... They will not give any money to Qatar.
I did not say that, just to make sure. So what is the question? What is the question?
Yeah, but the thing is, I'm telling these people...
Yeah, what is the question?
Focus on the Arab. But no, the question is an advice.
Yes. So first of all, I'm not a businessman. As we speak, I have PhD holders working with me, and we generate 250 publications just in 5 years, right? So I do a lot of research. So I'm not in the business department, I'm in the head technology department. Second thing, all this Qatar, UAE, they have a knowledge-based economy strategy. They have a knowledge. So they will not keep buying from you and others these technologies. They need to build their own technology, right? They need to try to build, to change the mentality to move from consumer, right? Consumer to producer. And this is very challenging, right? So our mandate at QMIC is to implement a vision. And that vision, we are contributing on that vision by a small percentage. The second point, I did not say that we want to generate money out of Labib. So, yes, I did not say that. Labib IoT platform, if you look at this, you have professional service there. And you mentioned yourself, right? Professional service is very critical for us, and this is what we did. So once you have a know-how, you can then provide it, give it for free, and provide the professional service. And this is how we generated money out of one of these startups, right? So generating money of platforms, this is useless strategy. Generating money from applications and professional service, this is the good strategy, right? But to power others to build their own applications that they are looking for, you need to enable them. You need to give them platforms, right? So we are not generating money out of Labib IoT. We're generating money out of the verticals and the applications.
So thank you. Thank you. Other questions? The last one. It looks like Qatar don't need money.
Thank you for your representation. I want to thank you in person, Professor Akilic, because he has spoke in the name of many of us, in person me. So at the point of view of a research person, here I get the point that I should focus first on the application field. Now, after listening to him and to you, so the research point and the application point, trying to build a bridge between the two, I get very confused. I didn't find a common point between the two. So my question to you is, as you, a professional person in the application field, do you think that Tunisia, compared to Qatar, can reach the same level or can have the same success that was shown with your company in Qatar? And we here as Tunisian researchers, what can we do exactly? So at what level are we going to search for application field as individuals, as universities, as startups, or are we going to try to join your company, for example, going out there, out of Tunisia? So there's a big confusion here. So.
Yeah, my understanding of this forum is not for researchers. My understanding of this forum is for entrepreneurs and talent people who really want to develop end-to-end solutions. I could have really presented something related to pure research. We are doing now pure research in blockchain. There was a question about the blockchain, how to use it in IoT. It's very challenging. Right? Blockchain for IoT is very good as a research problem that you can work on. We are doing other project about security and privacy, right? How you can do data analytics in data which is uncoded, I want the data to be stored in your side, but I want to be crypted. But please provide me the data analytics service as well. So this is very challenging, and there are many others. So the forum here is to present you some success stories. So to be stick to the title, we are presenting you some success story. Then from a research perspective, I will be more than happy to discuss and identify issues that you may consider to work on.
Thank you very much for your presentations. And just to add other things, that Tunisian have the brain and maybe Qatar have the money. So
last point, don't compare Qatar with Tunisia.
What I can propose for the IoT Tunisia is that if we can play a good role in Tunisia, that several people, young engineers or PhD students without works, they would like to be involved in the IoT, but they don't know how to do. It will be better, for example, to be a center of contacts. And if a businessman and one other from physics, one other from biology would like to meet, so we can play a good role on that. So thank you. We will, the third session, la troisième session. La troisième session sera à 14h15 dans cette salle. Enjoy your lunch. You will have the lunch outside. Thank you for coming and see you next time. Thank you.